Imagine waking up to a normal day. The sun rises, you go about your routine, everything feels ordinary. Now imagine that in the next 24 hours, your entire world will end. Not slowly, not over years, but in a single catastrophic day. 66 million years ago, the most powerful creatures to ever walk the Earth faced exactly that. They ruled this planet for 160 million years. They survived ice ages, volcanic eruptions, and countless other extinctions. But nothing could prepare them for what was coming. This is the story of the last 24 hours of the dinosaurs, the day the Earth stood still, the day that changed everything. Let me take you back. 66 million years ago, Earth looked very different from today. The continents were still moving into their modern positions. North America and Europe were just beginning to separate. India was an island racing toward Asia. The climate? Much warmer than today. No ice caps at the poles, and tropical forests stretched from the equator almost to the Arctic. This was the Cretaceous period, the golden age of dinosaurs. And they were everywhere. In what we now call North America, massive herds of triceratops roamed the plains. In the forests, packs of velociraptors hunted in coordinated attacks. And towering above them all, the undisputed king, Tyrannosaurus rex. Standing 17 feet tall and weighing 7 tons, T-Rex had a bite force of over 12,000 pounds, strong enough to crush a car in a single bite. With teeth the size of bananas and a sense of smell that could detect prey from miles away, nothing escaped the Rex. But dinosaurs didn't just rule the land. In the skies, giant pterosaurs like Quetzalcoatlus with wingspans of 40 feet soared on thermal currents, hunting from above. And in the oceans, massive mosasaurs, 50-foot-long marine reptiles were the apex predators, feeding on fish, sharks, and even other marine reptiles. It was a world of giants, a world perfectly balanced, a world that had existed, essentially unchanged, for millions of years. But on this particular day, 66 million years ago, something was different. The animals couldn't feel it yet. They had no way of knowing, because 100 million miles away, their doom was already in motion. This is where our story really begins. Not on Earth, but in the asteroid belt between Mars and Jupiter, 200 million miles from Earth. Billions of rocks, all orbiting the sun in the same direction. A cosmic highway that's existed since the birth of our solar system. But about 100 million years before our story, something went wrong. Two massive asteroids collided. The impact shattered them both into millions of fragments. And this fragment, over 6 miles wide, was knocked off course. Its new trajectory? Straight toward the inner solar system. Straight toward Earth. For the next 100 million years, this rock drifted through the darkness of space. Silent, patient, inevitable. It passed Mars, it crossed through the asteroid belt again, and then it entered Earth's neighborhood. Here's something incredible. This asteroid came within 250,000 miles of our moon. If it had hit the moon instead, everything would be different. Dinosaurs might still rule Earth, humans might never have existed, but fate had other plans. As the asteroid entered Earth's gravitational field, it accelerated, faster and faster, from 40,000 miles per hour to 45,000, 50,000, 70,000 miles per hour. This wasn't just rock, it was a mixture of stone, metal, and ice. And now, after a journey of 100 million years across 200 million miles of space, it was about to arrive. Let's go back to Earth, to the Yucatan Peninsula in what is now Mexico. It's early morning, the sun is rising over a shallow sea. A herd of Alamosaurus, the largest dinosaurs in North America, are feeding on the coastal vegetation. These giants are 70 feet long and weigh 30 tons each. To sustain that bulk, they need a ton of leaves every day. One female has just laid a clutch of eggs. Under normal circumstances, only 1 in 3,000 of these eggs will produce a mature Alamosaurus, but these aren't normal circumstances. 3,000 miles north in what will become Montana, a T-Rex is teaching its young to hunt. The babies are only a few inches tall now, but in 18 years they'll grow into the most fearsome predators the world has ever known. Nearby, a herd of triceratops are gathering at a watering hole. Males are challenging each other for mating rights, a ritual that's been repeated for millions of years. And hiding in burrows beneath their feet, tiny mammals about the size of possums wait for nightfall. These are our ancestors, small, insignificant creatures that only come out when the giants sleep. Everything seems normal, everything seems safe, but 20 minutes away, traveling at 45,000 miles per hour, the asteroid is crossing the moon's orbit. In less time than it takes to cook dinner, it will cross the 240,000 miles between the moon and Earth. Target: the Yucatan Peninsula, the exact spot where those Alamosaurus are feeding. The dinosaurs have no concept of space, no understanding of asteroids, no way to see what's coming. As the asteroid hits the upper atmosphere, friction begins to heat its surface. The air around it compresses and superheats to thousands of degrees. It's no longer just rock, it's a fireball, burning brighter than 1,000 suns, traveling faster than any bullet ever made. And now, finally, the dinosaurs can see it. A bright streak across the morning sky, growing larger by the second. Some animals look up, curious. Others sense danger and begin to run. But there's nowhere to run to. Nothing can save them now. 5 seconds to impact. 4, 3, 2, 1. The asteroid hits the shallow waters of the Gulf of Mexico with the force of 100 million megatons. That's more powerful than every nuclear weapon ever built, detonated at once. In less than a second, the asteroid completely disintegrates, vaporizing along with billions of tons of Earth's crust. A crater begins to form, 20 miles deep and 120 miles wide. But impact isn't instantaneous. Hidden within this cataclysm are dozens of discrete events, each one more devastating than the last. First, the light. Even before the asteroid physically touches down, the sheer heat and brightness creates a flash visible from thousands of miles away. At ground zero, temperatures reach 35,000 degrees Fahrenheit, hotter than the surface of the sun. The Alamosaurus herd doesn't burn. They don't even have time to burn. They simply cease to exist, vaporized in a fraction of a second. But even 500 miles from impact, the heat is unbearable. The intense light burns shadows of dinosaurs onto rocks, like nuclear shadows at Hiroshima. Flesh becomes transparent, eyeballs boil, water in their skin explodes as steam. Second, the shockwave. Rocks the size of mountains are thrown into the air at supersonic speeds. They'll come down later, raining fire across the continent. Third, the earthquake. An earthquake measuring 11.1 on the Richter scale, 60 times more powerful than any earthquake in human history. It ripples through the planet. The shockwave travels at 3 miles per second, circling the entire Earth multiple times. Mountains crack, valleys collapse, forests are flattened like grass. A pulse of air moving faster than the speed of sound radiates outward in a perfect circle. It strips skin from flesh, tears trees from the ground, and flings 30-ton dinosaurs through the air like toys. 5 minutes have passed. In those 5 minutes, every living thing within 1,000 miles of impact is dead. But the worst is yet to come. The ejecta cloud. The impact has thrown 70 billion tons of pulverized rock into the upper atmosphere. This is the ejecta cloud, and it's about to circle the globe. Remember those T-Rex in Montana? They're 3,000 miles from impact. So far, they've felt nothing except a distant earthquake. A pair of Quetzalcoatlus, giant flying pterosaurs, are roosting on a clifftop. From their vantage point, they can see something strange on the horizon, a glow like a second sun rising. That's the fireball from the impact, visible from 3,000 miles away. That's how big this explosion was. 16 minutes after impact, the seismic waves reach Montana. The ground begins to shake. Trees sway, rocks tumble. The Triceratops herd panics, scrambling up the valley slopes. But then something worse arrives. The sky grows brighter and hotter. The ejecta cloud is moving at 10,000 miles per hour. As it spreads across the atmosphere, trillions of tiny particles re-enter from space. The friction creates intense heat, turning the sky into an oven. On the ground, temperatures tick upward. 100 degrees, 120, 150, 200 degrees Fahrenheit. Animals run for cover. Some hide in caves, others dive into rivers, but most have nowhere to go. And then the ejecta begins to fall, not as dust, but as burning rocks. Millions of superheated stones rain from the sky like a meteor shower, except each one is on fire. The heat ignites everything. Dry vegetation explodes into flames. Within hours, massive wildfires are burning across North America, Europe, and Asia. Even on the opposite side of the planet, in what is now Mongolia, the effects are catastrophic. The ejecta cloud arrives 90 minutes after impact. Air temperature rises to 300 degrees Fahrenheit. Any dinosaur caught in the open simply cooks alive. A pair of Sauronoithides, small, intelligent predators, take shelter in a cave. They share this refuge with their prey, oviraptor, herbivores, natural enemies forced into an uneasy truce by a common threat. 12 hours after impact, fires are burning on every continent. The sky is black with smoke and ash. Temperatures are either scorching hot or dropping rapidly as the sun is blocked out. Some dinosaurs have survived, but survival at this point just means you get to die slower. The tsunami. 3 days after impact, the fires are still burning, the earthquakes continue, and now new threats emerge. Along the coasts, survivors notice something strange. The ocean is pulling back, exposing miles of seafloor. A small group of Triceratops, desperate for food, see an island in the distance covered with green vegetation, untouched by the fires. They begin walking towards it across the exposed seafloor. They don't realize what's coming. The impact created seismic waves in the ocean. These waves have been traveling around the world, growing larger as they funnel through shallow waters. Now they're returning, mega-tsunamis. Walls of water 300 feet tall, traveling at 500 miles per hour. The Triceratops see it too late. The wave hits the island, destroying everything in seconds. When the water recedes, nothing remains. Around the world, 13,000 miles of coastline are completely destroyed. Entire ecosystems gone. But the Earth isn't finished. The impact's shockwaves have traveled through the planet's core, triggering volcanic eruptions around the globe. Dormant volcanoes that haven't erupted in millions of years suddenly come to life. They spew more ash, more toxic gases, more darkness into an already darkened sky. 1 week after impact, the sun is completely blocked. Day and night are indistinguishable. The planet is entering what scientists call impact winter. Without sunlight, plants begin to die. First the small plants, then the trees. Photosynthesis stops. The foundation of the food chain crumbles. The herbivores, already wounded, traumatized, and scattered, now face starvation. Without plants, they have nothing to eat. Remember those Alamosaurus, the ones that needed a ton of leaves every day? There are no leaves anymore. They wander through ash-covered wastelands, growing weaker by the day. The carnivores fare slightly better. They can eat the herbivores, but even this won't last long. Food becomes so scarce that T-Rex are forced to fight each other for every scrap. Former hunting partners become enemies. An ankylosaurus, a heavily armored herbivore, faces down a T-Rex over a single small bush, the last piece of vegetation for miles. They fight to the death. Neither wins, both die. The bush isn't worth the energy they spent fighting for it. Weeks turn into months, months turn into years. The darkness continues. This is the true killer. Not the impact, not the fires, not even the tsunamis. It's the cold, the darkness, the endless winter. Global temperatures have dropped by 50 degrees Fahrenheit. In some places, it's freezing for the first time in millions of years. The surviving dinosaurs, already starving, now face hypothermia. Their cold-blooded metabolisms can't cope with these temperatures. And then comes the acid rain. The volcanic eruptions have filled the atmosphere with sulfur dioxide. When it mixes with water vapor, it creates sulfuric acid, which falls as rain. Water sources become poisoned. The few surviving dinosaurs that find water often die from drinking it. In low-lying areas, another killer emerges, hydrogen sulfide, one of nature's most toxic gases. It bubbles up from volcanic activity underground. It's invisible, odorless, and deadly. An oviraptor approaches a watering hole in Mongolia, the same watering hole that saved her life twice before. But the hydrogen sulfide has pooled in the low area. She breathes it in, her lungs paralyze, she suffocates within minutes. Back in Mexico, something miraculous has survived. Remember those Alamosaurus eggs? One of them, buried under a thin layer of cool soil, protected from the heat, has survived. Inside, a baby Alamosaurus is growing. It hatches. A tiny Alamosaurus emerges into a dead world. There's no herd to protect it, no vegetation to eat, no future. It survives for 3 days, then joins the billions that came before. This is how they die, not in a single catastrophic moment, but slowly, one by one, as their world becomes uninhabitable. Populations dwindle. 2.5 billion dinosaurs reduced to millions, then thousands, then hundreds, and finally, one. The last dinosaur on Earth takes its final breath. The species that ruled for 160 million years is gone. The Earth is silent. But not everything died. Remember those tiny mammals hiding underground? They survived. Their small size meant they needed less food. Their burrows protected them from the heat and cold. Some birds survived by diving underwater. Some hid in tree hollows.
Some got lucky. Crocodiles and alligators living in water were insulated from the worst of the temperature swings. Fish deep in the oceans never saw the fires, never felt the heat. Turtles, with their slow metabolisms and ability to burrow, waited out the winter in mud. Years pass. 5 years, 10 years. Finally, the dust begins to settle. The sun breaks through, and something incredible happens. Life returns. Ferns, tough, resilient ferns, are the first to come back. They spread across the planet in a carpet of green. Then insects, then small plants, then trees. And the mammals? Those tiny, insignificant creatures that hid while giants died, they explode in diversity. Without dinosaurs to compete with, they grow larger. They spread to every continent. They diversify into thousands of species. Millions of years pass. The mammals continue to evolve. And then, about 60 million years after the asteroid, a new group emerges. Primates. They develop bigger brains. They learn to use tools. They come down from the trees. And eventually, us. Humans. We build cities, we create technology, we study the stars, and we dig up the bones of the dinosaurs, trying to understand what happened to them. Today, you can still see the impact crater. It's called the Chicxulub crater, buried under the Yucatan Peninsula in Mexico, 120 miles wide, a permanent scar on our planet. And around the world, in rock layers 66 million years old, we find a thin band of iridium, a metal rare on Earth but common in asteroids. This is the signature of the impact, the dinosaurs' epitaph. Everything we are exists because they died. Our evolutionary path was opened by an asteroid. Our cities stand on the ruins of their world. And here's the terrifying truth. It could happen again. Right now, astronomers track thousands of near-Earth asteroids. Most are harmless, but some have orbits that cross Earth's path. We're the first species in Earth's history with the knowledge to see it coming, and maybe, just maybe, the technology to stop it. The dinosaurs ruled for 160 million years. Modern humans have existed for only 300,000 years. We're infants by comparison. So the next time you see a shooting star, remember, we're all living on borrowed time. The universe is vast, chaotic, and beautiful. And sometimes the universe reminds us just how fragile life really is. The last day of the dinosaurs was the first day of our world.